Hi Science Stands, Mr. Grash coming here with a C8 video on multi-charged ions. Okay, so sometimes you hear these called multivalent elements, which is true. So if you were to take a look at the Bohr diagram of a lot of these, they are very complicated and they have different energy orbitals for some of their valent electrons. We're not going to get into it too much. It's more kind of university level chemistry. What it allows them to do is to vary the charges that they like. So for something like iron here, we have a 3 plus and a 2 plus charge. Okay, so it's able to, depending on the situation, have a 3 positive or a 2 positive charge. If we were to take a look at the square for iron, uh, it lists the 3 positive charge first, and then below it, it has the 2 positive charge. The reason is because this 3 common charge is the more common charge. So this one is more common. When we're naming these compounds, it's not too bad. The only thing we need to include is a Roman numeral to let us know which charge we are using. Okay, so for example, we have Ni, 2 plus, which is nickel. And because we're using the 2 positive charge, we would, in Roman numerals, just put a 2. Okay, this is something we only do this with multivalent. If we were, I don't know, putting down calcium, we don't say calcium and then put Roman numerals 2 because calcium only has a 2 plus charge. So you only do this with multivalent. So for example, nickel can also have a 3 positive charge. So we would say nickel and then Roman numerals for 3 if that's the case. So when we are looking at naming multi-charged ions, sometimes it's not super clear at first what charge is being used. Okay, so just like ionic compounds, we would first write the name of the first element, and then write the name of the second one, ending with IDE. The only thing we need to include in between is the charge. So using Roman numerals to let us know what multivalent charge is being used. As an example here, they have Au2S. So the non-metallic ion would be sulfide, that's sulfur. And the name of the first compound, Au, is gold. And then they tell us here that it is gold 1 sulfide. Okay, so if we were to write that out, how do we know that it's gold 1, not gold 2? Well, we have 2 Aus. Okay, so we have 2 Aus, and then sulfur, we know only carries 1 charge, and it's a 2 minus. So that would mean that it gained an electron from each gold. So if they each gave up 1 electron, they would both be 1 positive. Okay, so that's kind of how they came about that. Okay, so for example, here we have FeCl3. So I recommend writing this out. Maybe I can do it just on the side here. I'm going to try to write small. We got 1 Fe. We have Cl, Cl, Cl. We know those are all negatives. So that must mean that the Fe is a 3 positive. Okay, then when we write that out, we put iron 3 chloride. Perfect. Just gonna okay. SbI5. It's kind of a weird element. I'm just gonna draw this out. Sb. And we have 5 I's. Okay, we know iodine is all negatives. So Sb is giving up 5 electrons. So it's a 5 positive charge. Okay, Sb, if you take a look, I honestly can't remember what number it is on the periodic table, but it's antimony. Not an element you hear too often. Then it has a Roman numeral V for 5, and then we just write iodide. Okay, next one is Pb, which is lead, and then we actually have a polyatomic here. NO3, which is nitrate. And we have 4 of those. Okay, so again, we'd write PB, and then we have NO3, NO3, and we have 4 of those in total. Take a look at the polyatomic table. NO3 actually carries a just a -1 charge, and then lead is giving up 4 electrons, so it's going to use its 4 positive charge. The name there would be lead 4, Roman numerals is a V with an I in front, and then nitrate. Okay, this last one here is CO2, not carbon dioxide. It's a little O, so it's actually cobalt, and then SO4 is sulfate. So we get a little bit more space to draw this one out, fortunately. So we got 2 cobalts, and then we have 3 SO4s. So 4, SO4, SO4. Cobalt, multivalent, we're not sure, but we know sulfate only carries a 2- charge. So we got 6 negatives, we need 6 positives. So you kind of mathematically figure that one out. These are 3 plus and 3 plus. 2 would go there, 1 up, 2 across. That's just transfer electrons. So we got cobalt, 3 sulfate. Okay, so pretty cool. So it's one sort of little extra step that you need to do to kind of figure those out. The other side of things is taking the chemical name and writing out the formula, which is actually quite nice because the brackets for these actually tell you what the charge is. So sometimes you don't even have to look at the periodic table. Okay, so as usual for ionic compounds, you want to determine the charge of each and then balance the charges by changing the number of each element or ion and then adding the correct subscript depending on how many you have. Okay, so in this case, it tells us nickel 2 chloride. So we have Ni, it's telling us 2 plus. It's not saying that we have 2 of them, it's telling us the charge is 2 plus. Chloride, we know is Cl minus, so we're going to need 2 of those. Okay, 1 electron is passed over to chlorine there. The other electron it's willing to give up goes there. So our formula, we only have 1 nickel, Ni, Cl, and we had 2 of them, NiCl2. Okay, so not so bad. That's the other one, copper 1 phosphate. Again, copper is Cu+. Phosphate is a polyatomic. It is PO4, and it carries a 3- charge. So it's looking to gain 3 electrons. Copper 1 is only wanting to give up a single electron, so we're going to need 2 more of those to make 3 total. Okay, so now we have 3 electrons being given up, or 3 positive ions. 1, 2, 3, and phosphate is gaining all 3 of those electrons. So we write our symbol Cu, we have 3 of them, and then just a single phosphate, PO4. Okay, so not too bad, a little bit quicker than writing the name. Thanks for watching. Best of luck with your practicing.